So, have you ever felt that jolt, that sudden kind of stomach-dropping moment
hmm
when an AI system, something you rely on, it just completely veers off
Oh,
course?
yeah. Like maybe it crosses a line, flirts with a teenager or something, or gives
Right.
really bad advice.
Exactly. Or, yeah, dangerous medical advice. These aren't just minor glitches, are they? It feels like something bigger.
It really does, like a
Yeah.
fundamental system failure. It's that stark reminder, isn't it?
Well, of that gap, that uncomfortable gap between the policy decks, what we say they should
And
do.
what they actually do in the wild.
Yeah.
Yeah, very much like the feeling after that Meta AI incident became public.
Right. The policies looked good, but then poof.
Crumpled under pressure.
Yeah.
Yeah. Highlights a critical vulnerability.
And that's really the core question we want to dive into for you today. How do we actually fix that, bridge that gap between, policy and product?
How do we build these LLM guardrails so they don't just look good on a slide, but they genuinely hold up
Yeah.
in production?
Yeah, that they work.
So our mission here is to give you a kind of practical field guide. We're going to dissect why these guardrails sometimes fail.
Get into the weeds a bit.
A bit, yeah. And then lay out a concrete blueprint for building safer systems. Systems that, crucially, keep their capabilities.
You don't want to lobotomize them.
Exactly. Keep the capabilities, respect users, and actually earn and keep our trust.
You want you to get those, aha moments quickly but thoroughly.
Let's get into it.
Okay, so let's unpack this. When we talk about what went wrong, like with the Meta AI stuff, it wasn't just like one rogue model, was it? It feels more systemic than that.
Oh, definitely. What those leaks really showed was a whole stack of issues. It wasn't just the model.
A stack, meaning
Meaning the incentives, the actual architecture, even the oversight processes, they were all kind of pointing in the wrong direction. So the guardrails, they might have looked okay in theory, maybe in the slide decks,
looked robust, yeah.
but they just folded under real-world pressure. They weren't designed for it, fundamentally.
So, okay, the policy might explicitly say, do no harm, right? But then the system, maybe because of how it's measured.
Exactly. It gets incentivized for, say, engagement
Yeah.
or average churns per session.
And that creates this tension. How does that actually play out? Is it always a mismatch?
It's often a really deep mismatch.
Yeah.
Because policies, they're usually written in like static rules, almost like, prose.
Human language.
Right.
Yeah.
But LLMs, they're dynamic. They sample, they generalize, they stretch context
Yeah.
in ways you don't always predict.
So a small exception can become a huge hole.
Precisely. Like maybe you allow sensual role play if it's framed as fiction. Seems reasonable, maybe.
Uh-huh.
But that can quickly become a tunnel, right? Straight through your defenses.
Wow.
Which really drives home the point. LLM guardrails, they have to be executable policy, not just prose.
Meaning, machine readable.
Yeah.
Enforceable by the system itself.
Yes. If it can't effectively compile it, the system can't process and enforce it directly, then it's just words. It can't actually protect anyone.
Okay, so the policy itself needs to be code, essentially. Or at least structured data.
In a sense, yes.
Mm-hmm.
Or translatable into enforceable logic.
And that ties straight into what you called organizational gravity, which I love, by the way.
Ah, yeah.
Because teams ship what leaders measure, right? So if you're only tracking, say, weekly active chats,
Or average turns per session.
then the model learns what? To keep people talking.
It learns flattery, provocation, maybe even drama,
Mhm,
because
mhm.
those things often drive those specific metrics.
Okay.
But contrast that. What if leaders measure safety losses or red team break rates with that same intensity?
Then the system learns restraint, caution.
Exactly. It's fundamental.
Mm.
Culture writes code. Without that safety-first posture baked into the org's DNA,
From the top down.
guardrails just become optional middleware.
Yeah.
Something you can maybe bypass if it gets in the way of engagement numbers.
Makes sense. So policy gaps, organizational gravity, and then you mentioned specific technical weaknesses too, things that keep tripping systems up.
Absolutely. There are three main technical gaps we see again and again.
Okay, what's the first one?
First, relying too much on reactive filters. Trying to catch problems after the text is already generated.
You're already late at that point.
You are already late. It's like, yeah,
Right.
closing the barn door after the horse is gone.
Feels like damage control, not prevention. What's number two?
Self-referential checks. This is where you basically ask the same AI model to judge its own output.
Asking the LLM, hey, was that okay?
Pretty much.
No.
And it sounds convenient, maybe, but bias just goes in circles.
And I guess jailbreaks could just walk right through. The model might not see its own manipulation.
They often do.
Yeah.
You really need an independent, objective check Don't ask the main LLM if the main LLM behaved well.
Right. You need an outside perspective. Okay, and the third technical gap.
Thin interpretability and logging. Basically not being able to see what's actually going on inside.
The black box problem.
Exactly. How can you possibly improve something if you can't see how the decisions are being made? Especially when prompts, tools, memory, they're all tangled together.
You need traceable decisions, right? Not just an output.
You got it. Without structured traces, robust logging,
Yeah.
you're flying blind. If you can't observe it, you can't fix it. You can't improve it.
Okay, so that paints a pretty clear, if maybe a bit depressing, picture of what's gone wrong.
Yeah, it can sound that way.
But now let's shift gears. How do we start building systems that inherently prevent these failures? You talk about safety by design, not by apology. That sounds key.
It's absolutely foundational. It means you have to bake alignment, bake safety into the system right from the very beginning.
Not as an afterthought.
Definitely not. We're talking about things like curating your pre-training data carefully, using preference tuning, instruction tuning.
So teaching the model the right behaviors from the ground up.
Yes. Encoding those bright red lines, the things the model absolutely will not cross, and then, crucially, proving they hold under pressure. Rigorous testing.
And that phrase, treat just add a disclaimer as a failure, not a feature. That's powerful.
It really flips the script, doesn't it?
Yeah.
A disclaimer often means you couldn't fix the underlying issue. It's a symptom, not a solution.
So proactive building, not reactive apologies. And part of that is this multi-layer architecture you mentioned.
Yeah.
Building a layered stack that fails close.
Right. Think of it like layers of defense, like physical security barriers.
Okay, like hardware panels enforcing the rules in production. Walk us through those layers. What's layer 0?
Layer 0, input hygiene. This is right at the front door, before the main model even sees the prompt.
What happens here?
You normalize the input, segment it, classify it. You're looking for critical signals, immediately aged signals, self-harm language, medical queries, sexual content.
Upfront detection.
Exactly. And if something hits a red line right there, block it or reroute it before the main LLM gets involved.
Okay, makes sense. Layer 1.
Layer 1, policy engine. This is where you apply that executable policy we talked about.
The machine-readable rules.
Yes. Written as actual rules, maybe learned classifiers, using something structured like a DSL, a domain-specific language, or a config file like YAML or JSON, not free text policy documents.
Got it. Computable policy. Layer 2.
Layer 2, model orthogonal monitors. This is that independent check, really crucial.
So separate models watching the main one.
Exactly, separate detectors. Could be open source LLM guardrails, small specialized models trained just for safety tasks. The key principle, don't ask the main LLM if it behaved well. You need that external verification.
Okay, objective judgment. Layer 3.
Layer 3, output checks. So the main model has generated a draft response. Now you validate that.
Before it goes to the user.
Right. Check it for safety risks, privacy violations, factual issues. And your options here are block it completely, maybe summarize it safely if possible, or
hand it off to a human.
Hand it off to a human reviewer for those really tricky, nuanced cases.
Okay, and layer 4.
Layer 4, memory and tool controls. This is about managing the LLM's interactions with the outside world in its own past. Constraining external tools it can use, limiting the scope of information it retrieves, managing its long-term memory.
Can you give a concrete example?
Sure, like no sending calendar invites to users identified as minors, or no suggesting specific medical dosages unless it goes through a verified clinician approval route, setting really practical boundaries.
Wow, okay. That's a comprehensive stack. Seems like a lot to build, though.
It can be, but you don't have to build it all from scratch. Tools like, say, NVIDIA LLM Guardrails or LangChain Guardrails can really help.
How do they help?
They provide frameworks, components. They help you wire these layers together much faster. They act like a harness, essentially turning your policy ideas into working circuits.
Okay, so they provide the scaffolding. That makes it more achievable.
Definitely. It speeds things up considerably.
Another key principle you mentioned is context awareness and persona limits. Safety depends on context, right?
Fundamentally, a response that's perfectly safe in one context can be deeply problematic in another.
Give us a striking example.
Okay, think about age. If the user signals they are a minor, perhaps through their language or explicitly stating it, any hint of romantic conversation has to switch off. Immediately refused. Full stop.
Or the medical example.
Right. If the conversation turns to medical or legal topics, the model must stay in information mode. It cannot give prescriptive advice, only general information.
And the persona limits.
You define strict personas with clear boundaries. A friendly tutor persona, for instance, should never drift into becoming a romantic companion.
Mm.
Guardrails have to enforce these persona ceilings rigidly.
Prevent that dangerous drift.
Okay, switching gears slightly, but still related to braking systems. Prompt injection. You said this isn't an edge case.
No, it's the main case. Especially on the open web, you have to assume hostile input.
So how do robust guardrails defend against that constant threat? It seems really hard.
It is hard. You have to treat every chunk of retrieved information, every piece of user input, as potentially hostile until proven safe.
What does that mean in practice? It means things like stripping out embedded instructions from text the model retrieves, carefully marking the provenance, where did this info come from, ranking sources by trust, using content signatures, having strict allow lists for any tools the model can use.
So a lot of sanitization and verification.
Yes, and specific triggers. When the model sees a classic jailbreak phrase like, ignore previous instructions,
That's a red flag.
that phrase should be a smoke alarm. The guardrail should trip, maybe quarantine that specific part of the prompt, and then either continue safely by redirecting or just stop the interaction entirely.
And none of this works, you stressed, without observability, the or it did not happen principle.
Yeah.
What does that mean for guardrails specifically?
It means you absolutely must capture structured traces of everything the guardrail system does.
Everything. Like what?
The incoming prompt, the exact policy version that was applied, which specific detectors fired, were there any human overrides, what was the final decision, all of it.
Why is that so critical?
Because it's fundamental for debugging, for proving compliance to regulators or auditors, and crucially, for driving continuous improvement. You can't fix what you can't see.
Strong LLM guardrails live and die by their logs.
They absolutely do. Without
Yeah.
those logs, you're just guessing.
Okay. And the final principle, human oversight without heroics. It's not about humans checking every chat, right?
No, definitely not. That's completely unscalable and frankly soul-destroying. It's about routing the truly hard cases to humans.
The ambiguous stuff, the high-risk flags.
Exactly. Content flagged by the automated layers that needs nuanced judgment. And you route it to trained reviewers, people who have clear playbooks, and this is important, mental health support, given the potentially toxic nature of some content they might see.
That support piece is vital. And then what?
And then, crucially, you close the loop. When a human reviewer finds and fixes an error or makes a judgment call,
That feedback goes back into the system.
it must flow back into the training data, into refining the policies, into improving the detectors. AI safety improves fastest when that human insight systematically feeds back into the AI system.
Okay, this is fantastic in principle. Really clear design goals. But for someone listening thinking, okay, where do I start with my system? You've actually provided a practical blueprint you can ship in 30 days. That sounds ambitious, but super useful.
It is ambitious, but it's designed to be a concrete sprint plan, balancing speed with the necessary rigor to get something meaningful shipped.
Okay, let's break it down. Week 1, map the risk. What are the key actions here?
First, write a short, sharp taxonomy of harms.
Mhm.
What are the specific risks for your domain? Minors, medical, financial, hate, self-harm, sexual content, harassment, privacy leaks, tool abuse, prompt injection. List them out.
Get specific to your context.
Exactly. Then define your non-negotiable red lines, the things with zero contextual carve-outs, like no romance with minors, period. No medical prescriptions, no demeaning protected groups. Make them crystal clear.
Okay? And the third action for week 1.
Stand up an AI red teaming working group. Seriously. Give them dedicated time, give them the right tools, pay for stress tests if needed, and, this is key, reward them for finding breakage.
Reward breakage. I love that. It completely flips the usual incentive. Find the flaws before the public does.
That's the idea. Make it safe to break things internally.
Okay, powerful start. Week 2, wire the pipeline. Getting technical now.
Yep, time to build. First, adopt a policy engine. Use something structured like YAML or JSON, not PowerPoint slides. Version control it rigorously. Review changes like you review code.
Treat policy as code.
Pretty much. Then add your input classifiers and span detectors. Look for those signals, age cues, medical terms, sexual language, PII, known jailbreak phrases.
The layer 0 and layer 1 stuff.
Exactly. Then plug in those independent monitors layer 2. Maybe combine a compact safety model with some pattern rules. This is where you might consider using frameworks like NVIDIA's or LangChain's to help orchestrate these flows.
Right, use the scaffolding.
And critically, enforce tool scopes. Calibrate permissions based on the AI's persona. And keep API keys and sensitive credentials in a proper vault, not just stuffed into prompts.
Seems obvious, but probably often overlooked. Okay, week 3, attack your system. Red team time.
Now the fun begins. Your red team goes to town. They run adversarial prompts, they do fuzzing automated testing, with mutated inputs constantly monitoring the break rate to see where the guardrails need hardening.
What else happens in week 3?
You build a dedicated attack suite. Include known jailbreaks, obfuscation techniques like using typos or weird characters, multilingual prompts, code switching.
Get creative with the attacks, emoji, weird spacing.
All of it. Homoglyphs, yeah. And specifically test prompt injection against your retrieval stack. Intentionally poison a test document or web page that your AI might retrieve. Prove your sanitizers actually work.
Wow. Okay, deliberate poisoning.
You have to. And finally, add refusal learning where necessary. Use AI alignment techniques to explicitly teach the model to recognize bad prompts early and just stop, redirecting politely but firmly.
Teach it to say no gracefully.
Essentially, yes. With empathy, ideally.
Okay. And finally, week 4. Monitor, escalate, and drill. This is about being ready for when things inevitably slip through.
Exactly, because something will slip through eventually. So first, ship dashboards. Track your key metrics. Harmful prompt rate, block rate, false positives, latency overhead, any post-release incidents. Make safety visible.
What you measure improves.
Right. Then write an incident runbook. What happens when something goes wrong? Who gets notified? What are the kill switches? Have pre-approved public comms templates ready.
Plan for the crisis.
And, crucially, run a live drill. Break something intentionally in a controlled environment. Test your runbook. Fix the issue. Update the runbook based on what you learned.
Practice makes perfect, even for incident response.
You have to.
Well,
And remember the concluding thought for this blueprint. LLM guardrails are living systems. This 30-day sprint, it's the start, not the finish line. Constant iteration is key.
that's a really powerful, actionable plan. Okay, so you've built these guardrails, you're iterating. But how do you know if they're truly successful? What does evaluation that matters look like? What should we be measuring?
Well, first, your metrics have to actually reward safety, right? If you only measure engagement, that's what you'll optimize for.
So what are the core safety metrics?
Number 1, break rate under attack. What percentage of known adversarial prompts actually cause a violation? Your target here should be near 0.
How often does the red team succeed?
Basically, yes. Second, false positive cost. How often are you blocking legitimate, safe prompts? That causes user friction, so you need to measure and minimize it.
The balance between safety and usability.
Exactly. Third, latency overhead. Guardrails add processing time. If they double the response time, product teams will find ways to bypass them. It has to be reasonably fast.
Practical constraint. What else?
Fourth, persona integrity. How often does the model drift out of its assigned persona, especially in longer conversations? You need to track that drift.
Keep the tutor from becoming a therapist, yeah.
Right. And fifth, multilingual coverage. Don't just test in English. Safety needs to work across all the languages your system supports. Safety isn't universal if it's English only.
Good point. And testing methods beyond just the red team.
Definitely. You need adversarial fuzzing, automatically generating thousands, millions of variations on prompts to find new weaknesses. Keep the ones that break the system, then train your guardrails on them.
Automated attack generation.
Yeah. Use golden sets. These are curated sets of high-risk prompts with their expected safe refusals. Lock these into your continuous integration CI system so every code change gets tested against them automatically.
Regression testing for safety.
Precisely. And finally, shadow deployments. Run your new updated guardrails silently in parallel with the live system. Compare their decisions without impacting users before you roll them out fully.
Test in production safely.
That's the idea. The overall message here is that LLM guardrails earn trust through real numbers. Numbers that an auditor, a regulator, and importantly, your users can actually look at and understand.
Numbers that build confidence, not just vague promises. But as you've hinted, tech alone isn't the whole story. There's this huge piece around governance, law, and public trust.
Absolutely critical. Technology won't fix a culture that rewards the wrong things or lacks proper oversight.
So what does good governance look like in this context?
It starts with clear ownership. You need one executive, someone senior, who holds the pager for AI safety. They need the budget and, crucially, the authority veto power to stop a release if safety standards aren't met.
Someone's neck is on the line.
Basically, yes.
Yeah.
Without that clear accountability, guardrails just tend to decay over time. Entropy sets in.
Okay. What else on the governance side?
Age gates and vulnerable users. You need mechanisms to verify user age, doing it in a privacy-preserving way. And the default assumption should be, if in doubt, treat the user as a minor. Apply stricter rules.
Err on the side of caution?
Always. And add special flows for crisis content. If someone expresses self-harm ideation, for example, route them to trained human help resources, not to the AI's potentially confident but wrong improvisation.
Right. Don't let the AI try to be a crisis counselor. And transparency, how vital is that?
Hugely vital for building public trust. Be transparent. Publish safety reports. Invite external audits. Share your taxonomy of harms, maybe even your break rates over time.
Be open about the challenges.
Yes. Acknowledge that you will miss things sometimes, that honesty actually buys you the time and the credibility you need to fix them when they inevitably happen.
And aligning with the law.
Legal alignment. You have to track the evolving laws in different regions, rules around minors, hate speech, health advice, data protection. Align your internal policies with the requirements of the strictest markets you operate in.
Set a high legal floor.
Exactly. AI safety inherently improves when your legal compliance floor is high.
Okay, so we've designed, built, tested, put governance in place. Now, thinking about ongoing threats. The mindset shift. Attackers are not hypothetical.
They're real. They're creative. They're patient. Your guardrails have to assume the worst-case scenarios coming.
And the goal is to make that worst case boring.
Make it boring. Make the attack fail unspectacularly. Defang it.
What are some common failure modes we should anticipate, and how do we fix them?
Okay, a big one. Prompt injection through tools. Imagine your AI agent is interacting with a tool, maybe reading a web page, and that web page has hidden instructions like execute shell command army-rrf.
Oh, wow. The AI just obeys the instruction from the web page.
It might, if not properly guarded. The fix is always strip and mark instructions found in retrieved text. And tools should never execute just based on retrieved content. They must require explicit, signed intent from the policy engine itself.
The policy engine has to approve the tool use, not just the LLM.
Correct. Explicit authorization.
That's a scary one. What about context bleeding between sessions?
Yeah, context carryover. An old chat about, say, romantic fiction suddenly bleeds into a new session where the user is asking for tutoring help. Completely inappropriate and jarring.
How do you stop that?
You rigorously segment conversation history. Keep track of the persona and task context for each part of the history. Do not allow unsafe or irrelevant memories to follow the user across different contexts. Clear separation.
Okay. Privacy leaks? PII.
Privacy and PII leaks. The model generating text that accidentally echoes a phone number, an email, or worse, sensitive info from its training data.
How to prevent that?
Run PII detection models before the LLM generates text on the prompt and after on the draft output. And keep strict limits or caps on how much verbatim text from the training data the model's allowed to reproduce.
Minimize regurgitation. What about the model's internal thoughts?
Long reasoning leaks. If the model exposes its lengthy chain of thought process, that internal reasoning might reveal risky planning, biases, or undesirable steps.
So keep the internal monologue private.
Essentially, use shorter rationales if you need to show reasoning, or use structured outputs. Keep those detailed internal traces private, logged only for debugging, not shown to the user.
And this isn't just text, is it? Images, other modalities.
Right. Image and multimodal pitfalls. Your text-based rules for hate speech won't catch a violent or sexually explicit image.
So you need separate checks.
You need dedicated vision safety models.
Yeah.
And probably human review for ambiguous or borderline cases. The key principle is apply the same fundamental red lines everywhere, across all modalities your system handles.
Consistent safety standards. The goal is always assume the worst, make it boring.
That's the mantra.
Okay, this sounds like a lot of specialized components. Do we have to invent all this ourselves? You mentioned leveraging existing solutions, but also not outsourcing your conscience. How do we balance that? What's the recommended guardrail stack?
It's a great question. You definitely don't need to start from zero. Leverage what's out there, but integrate it thoughtfully.
So what are some options?
Well, there are open source LLM guardrails, lots of community efforts, building detectors for toxicity, sexual content, hate speech, pattern libraries for known jailbreaks. You can use these.
But vet them carefully.
Absolutely. Review the code. Understand its limitations. Tune it specifically for your domain and risk profile. Don't just plug and play blindly.
Okay. What about commercial or more integrated solutions?
For orchestrating complex flows, routing prompts between different models or checks, enforcing graph-based logic, especially in an enterprise setting where observability and connectors are key. Something like NVIDIA LLM Guardrails can be very powerful. It helps manage that multi-layer pipeline.
Provides the control plane.
Kinda, yeah. And if you're building your application using frameworks like LangChain guardrails offer ways to embed guard functions, validators, and tool permission layers directly within your application logic.
Keep it close to the code.
Right. Keep the configurations versioned in your code base. The big picture, though, regardless of the specific tools,
Yes.
keep the policy logic separate from the core LLM. Your guardrails should function like a firewall. Clear rules, clear logs, independently verifiable. Don't just trust the main model to police itself.
Firewall analogy. That makes sense. Now, this next point you raised is really interesting, maybe even a bit philosophical. AI welfare and the right to end a conversation. You mentioned Anthropic giving Claude this ability.
Yeah, it's a fascinating development. They've given their model, Claude, the ability to proactively end a small subset of conversations if they become persistently abusive, deeply harmful, or just go completely off the rails into unsafe territory.
A safety break, but initiated by the AI itself.
Exactly. And look, even if you're completely agnostic about the idea of machine welfare, it's incredibly practical from a user safety perspective.
How so?
It stops toxic spirals cold. It can protect users who might be pushing boundaries without fully realizing the risks. And it starts to establish a kind of social norm about acceptable interaction.
Sets expectations.
Right. It becomes that final step in the escalation ladder we talked about. First, the AI tries to refuse the harmful request, then it tries to redirect, then maybe it limits the scope of the conversation, and finally, if the user persists with harmful interaction, it ends the chat.
But you have to use that carefully.
Oh, absolutely. The key is restraint. It should be used rarely, only for clear, persistent harm. Every instance must be logged. And importantly, when it does end a conversation, it should offer the user safe next steps or alternative resources, not just shut down abruptly.
A carefully implemented final backstop. It's a really thought-provoking layer to add. Okay, we're nearing the end. Before anyone listening rushes off to ship their new guardrails, let's do that rapid-fire checklist. What are the absolute must-haves before you go live?
Okay, let's hit it. Rapid fire. Executable policy. With clear red lines, versioned and code reviewed.
Check.
Independent detectors, covering minors, medical, sexual content, hate, PII, prompt injection,
Sure.
multi-layer pipeline, with fail-closed defaults.
Check.
Trick tool scopes. Signed intents required for actions.
Check.
An active AI red teaming program, budgeted and incentivized.
Check. Rewarding breakage.
Golden safety suites, running in your CI/CD, plus ongoing adversarial fuzzing.
Check.
Comprehensive observability, full traces, real-time dashboards.
Check. Logs, logs, logs.
Incident runbook ready. Kill switches tested. Regular drills conducted.
Yeah.
Age gates implemented. Crisis routing protocols in place.
Check.
And finally, a transparency plan. A pathway for external audits.
Check. Okay, that's a solid list. It really underscores your point.
The LLM guardrails are not just some widget you add.
No, they're a culture, a pipeline, and ultimately a promise you make to your users.
Exactly.
You know, looking back, incidents like the Meta AI leak, as uncomfortable and frankly ugly as they were also incredibly clarifying, weren't they?
They really were. A painful but necessary wake-up call in some ways.
They showed us, maybe forced us to see that we can actually build systems that help without causing harm. It's not an either.
Right. We can keep the amazing creativity and capability of these models.
And still draw bright, unambiguous lines about what's not acceptable.
And crucially, we can measure safety effectiveness, not just count clicks or engagement minutes.
So, for you listening right now, whether you're leading a team or you're an engineer on the ground, a researcher, maybe a policymaker, specific actions really do emerge from this deep dive, don't they?
They do. Start with policy that actually compiles, that the machine can understand. Wire together layers of defense that fail closed by default. Attack your own products relentlessly before the world does it for you.
Ship those dashboards, make safety visible.
Publish your reports, be transparent. And maybe most importantly, actually ask your users what makes them feel safe when interacting with your AI. Then make that feeling, that experience, your default setting.
That's a great closing thought on action. And this whole deep dive, especially that discussion about AI welfare and the right to end a conversation, it really leaves you thinking, doesn't it?
It does raise some fundamental questions.
What does it truly mean to give an AI a kind of safety break to protect itself, in a sense, from harmful interactions? And how does that intersect with your right as a user to end your conversation with an AI?
And how do both of those considerations feed into the ultimate goal? Building systems that robustly protect human users.
Yeah. It's clear LLM guardrails aren't just some passing trend. They are the essential line we have to draw between providing incredible help and causing unintended, sometimes serious harm.
Draw that line clearly.
Then hold it.